In this lecture, we'll cover the concept of transverse Doppler effect when the source is not moving. Earlier we have done when the source is moving towards the observer in the straight path joining it. Suppose the source moves like this with respect to the observer at certain angle. What happens? Now here we have the velocity of source as VA is the velocity of source and it is in this direction. There is a listener who will be at distance L if you drop perpendicular to the motion of the source. Now we want to find the frequency when what is approaching the observer when the source is nearest. Now in this situation, take things in respect to time t. In time t, let this, if the velocity of the observer is va, this distance be va into t, and some wave which was emitted when the source was here, in that time the source has reached here and the sound has traveled this distance, which will be ct. So the observer is receiving the sound which was emitted in this direction, so that when he hears it, the source is this closest source is at distance L when he hears this wave which was emitted t seconds or time t back. Now we can easily find this angle theta. We know these two. So cos theta would be equal to VA upon C. Now we know in case of Doppler effect when source is moving, the frequency is C minus Vs. Vs is the speed of source along line joining the two. If this is this is source, this is observer, then Vs is the velocity line joining both of them. Here the wavefront which I have heard, which the observer has heard, has traveled this path. So this is the line joining the observer and source. What is the velocity component in this direction of the source, which will be VA cos theta. So the new frequency, so the frequency will be Fc upon C minus VA cos theta. And what is cos theta? Put the value of cos theta. So F dash would be Fc upon C minus VA into cos theta is VA upon C. So it becomes Fc upon C minus VA square upon C, and if you take C common, it becomes F upon 1 minus VA square upon C square. This will be the frequency which will be heard by the observer when the source is nearest to him. So this solves the concept of the transverse Doppler effect.